Welcome back to the second lesson. This is the concept of limit in the same chapter, limits and continuity. A quick reminder, if you have not watched the first lesson explanation, please go to the first lesson one and then come to this video. Now this one is where we start with limits. Thoroughly we investigate limits. Let's look into the learning objectives. Find the limit of a function algebraically and graphically if it exists. Study the existence of a limit by checking one-sided limits. Okay. Now we will go through both of these. We will come to know, you might find all these words, one-sided limit, algebraically, graphically, what is a limit exactly? We will see it in a while now. So keywords is one-sided limit, numerical evidence, graphical evidence. So we will look into all of this now. Let's look over here for a while. Now look at this function, x squared minus 4 divided by x minus 2. What if I ask you, what's the value of this function at x is equal to 2? How do we find it? Basically, to find the y value at x is equal to 2, I just substitute the y value, right? X value, sorry. 2 square minus 4 divided by 2 minus 2. Can you try doing this? Can anyone tell me what's the answer? Let's do this. 2 square is 4 minus 4, it will be 0. Okay. 2 minus 2 is 0. It's 0 divided by 0. You won't get an answer. It's undefined. Why? Because anything divided by 0 is undefined. You don't have an exact answer. It can be up to infinity. So now, how do we understand what's the answer? Look over here. You can see there's a hole because it's undefined at this particular point. As you go over here, there is nothing. So you can't draw it straight. It's a hole and then you can draw it. So it's undefined at that particular point. Now over here also you can see there is a space, there is a jump, see the values over here goes up above and this goes down. There is no continuity. It's not a straight line. See, it is a straight line basically, but at some point at x is equal to say 2 over here, you don't have an answer. So see, just the equation at 2, it is undefined whenever you have 2. Now what does this mean? Now limit is basically a concept to find not at this point but near this point, to understand what is the function, but not at this particular point but a nearby. So now over here, if you want to find the limit at this particular value at x is equal to 2, you will get the behavior of the before and after, and then you can understand what it is. Now it is like, I like to say this example generally. I mean, it may not exactly correspond, but you can just think about it. Now imagine you have a friend, like a person A and B, they both are good friends. Now B is a very good friend, but on a particular day, say a random day, 1st of May, what happened is B was very bad person, very rude, and he was not at all a good person to A. So on May 1st, and so what happened is this particular day is a very bad day. It's like undefined day, because at that particular day it was very it is not his general behavior. Maybe he was going through many things, so he was very bad to everyone. So now what you can do is you can see ahead, future and past. You can analyze before May 1st and after May 1st is always good, but only this particular point is not good. So you can just omit that because it's undefined, but generally is always good. So before and after is always good. So we can tell he is good. So over here you can see the values before and after. It is very, very close to 4. It's like 4.001. And so you can tell the limit is 1. It's not exactly on May 1st or not exactly at the value x is equal to 2, but the nearby values, and you're giving a range. Same way over here now, A and B, okay, these both are friends, but B is always bad. He is like not bad, he is like you can't predict it. Sometimes he'll go very high, sometimes he'll go very low. It's not at the same thing, if you just see before a particular day, say May 1st, he was a different behavior. Now, after May 1st is ultimately the opposite side, up and down, entirely different behavior. So you can't predict it. So in such cases like that, if you have limits up and down, we tell it is, not defined. It does not exist, sorry. Limit does not exist. So these are the two cases, okay? So now let's look into the problems. You will understand better. Now, this particular over here. Now, limit of x square minus 4 divided by x minus 2. We tried this just now in calculator. We'll get undefined at x is equal to 2. But what do we do is, we will compute some values of function x close to 2. Okay, so very close to 2. We have tried this in the last lesson. So instead of 2, let's take 1.9, 1.99. Let's go very close, like 1.999. And same way, more than 2 will be 2.1, 2.01 and 2.0001. Very, very close. And then you find the values. Now you can take out your calculator and just type, instead of x, 1.9. 1.9x square minus 4 divided, only instead of x you're putting 1.9. okay, again 1.9 minus 2, the answer is 3.9. Let me increase the 9 values. Let me add, total there are 5 9s. 1 2 3 4. So one important thing over here, you must have the same number of digits after the decimal in both the cases. So now it's 3.999. I'll just tell you what I mean. So now you have 1 point and 5 nines after decimal. If I have 6 nines over here, the answer will be entirely wrong. See, it's 39. So you must make sure x is the same throughout. If I have 5 decimal, same thing. Okay, so the answer is 3.9999. It's almost 4. Now same thing, let me change this to 2.0001. Okay, not 2.00 because you will not get the correct answer. It will be undefined. Over here, what I'm doing is putting very close to 2, but it's not exactly 2. And the answer is 4.001. So you can say that near and just before and after, it is always 4. So we can ultimately tell the answer as 4. In this, there is lots of explanation, but I'll just tell you how we read these notations. Okay, before this, let me just tell this. Limit of the function x square minus 4 divided by x minus 2 as x approaches 2. This is how we tell it. Okay, evaluate limit of the function. This is the function as x approaches 2. This line means it's approaching towards 2. Now over here we have minus and plus. Okay, over here you can say only minus. See, this x approaches 2 minus. What does that minus means? That means the limit of the function, that is x square minus, this is the function, right? We consider it as a function f of x. Limit of the function as x approaches 2 from the left side. That minus means left side. What does that minus indicate? Now here you can see in the graph, this is the whole, right? This is 2. So left side means it is 1.9. Over here x 1.9 is at left. Whereas if I have a plus sign, that means I have to consider these values, 2.001. Okay, so over here you're telling the limit as of f of x as x approaches 2 from the left side is corresponding to 4. It's not exactly 4, it's almost 4. Okay, same way. Now we have the tables, right? Let's see over here. The limit of f of x as x approaches 2 from the right side is also 4. From the right, that means these values, okay? 2.001. This is the plus sign. Now here, these two limits, plus and minus, from the left side and the right side. Now if x is equal to 2, so like this, from the left side and the right side, right means the right of it, positive side, plus left is the minus, negative side. So these are called one-sided limit. Now this is a one-sided limit because it just indicates one of the side, not both the sides. And this indicates another side. See, this one is another side. So we call them one-sided limits. Now if both both the one-sided limits are the same, then we say the limit of f of x as x approaches 2 is 4. So whatever is there approaching, that is the thing. Now we know it is 3.999. It's almost corresponding to 4. Here also we are corresponding to 4, and this is the answer. So now see over here, you can, I think so it's written, the notation of the limit as we have described over here intended to communicate the behavior of the function near some point of interest, not actually. This is very, very important. See, near at some point of interest. The point of interest was at x is equal to 2 over here, but not exactly at that point. Okay, not actually at that point, at that near that point. We know near this point over here it is almost 4, here also 4. So both the sides are corresponding to same answer. So we tell it is a 4. Okay, this is the thing. Also, you can simplify this. You can do this calculation by simplifying. Sometimes it will take more time to simplify. Some problems are easy to simplify, okay? Because if you're getting very complicated problem, you have to do the table method. That's the easiest, okay? Or instead of all that table method, you can just use a calculator. Now, x is 2, right? Just take values close to 2. One is less than and greater than. So first I'll take 1.99 square minus 4 divided by 1.99 minus 2. I will write this answer somewhere, 3.99, and then I'll change this value to 2.001 and this also 2.001, and the answer is 4. So I will just change this and write, and I'll compare. The first answer was 3.99. This is 4. Yes, both are almost 4. So yes, the answer is 4 and the limit exists. Only if both the answers are coming to a same answer, similar point. If they're different, it does not exist. So you can double check this. There is another method, that is to simplify them. You know, a square minus b square formula is a plus b, a minus b. So what we do is a minus b. A minus b. What we do is, now we use that identity over here, x square minus this 2 square. Instead of 4, we can write 2 square, it's 4, right? X minus 2, x plus 2. And now we can simplify this. The denominator goes, you're remaining with x plus 2. Substitute x, it will be 2 plus 2 equals 4. The answer is 4. But remember, whenever you cancel a denominator, you just can't forget this. Look, initially you had something. This was undefined at 2. Why? Because what is the denominator when you equate to 0? X is 2. X cannot be equal to 2, right? You can never have x equal to 2. Why? Because it will undefine this entire thing. So remember, this can be simplified, but note that x minus 2 cannot be equal to 0. Now, why I wrote equal to 0? To solve the x value, but it's not equal to, okay? It's always not equal to. So this is the way we can solve this problem. So this is the first problem. I took a lot of time, but the next coming problems, we'll do it quickly. So now over here, it's a problem where it does not exist. You can see the graph over here. One is going up, one is going down. Now, one in detail is already explained. All the details are there in this presentation. Now, I will just tell you how easily you can solve. Take out your calculator. And what you do is, x is 2, right? So, let me take 1.99 square minus 5 divided by 1.99 minus 2. The answer is 103.9. Okay, if it's a huge number, I generally tend to increase the zeros and just check. Okay, I'll increase the zeros. Now what's happening? It's jumping up high. So I realize that it's going up to infinity. Okay, now let me make it more zeros. 3 more zeros added up. And over here 3 more zeros. What's happening? The number is in terms of now billions, I guess. Now it is in terms of 10 million. So as I increase the decimal digits, this number is being huge and huge. So I can tell limit as x tends to 2 from the left side, negative side, limit of f of x. This is equal to positive infinity plus. Okay. Now the same thing, let me change and write 2.0001. Okay, let me take 2.1, 2, 3, 4, 5 and 1 over here. Same thing over here. So let me just change this quickly. 2.1, 2, 3, 4, 5 and 1. And the answer, you can see, limit as x tends to 2 from the positive side. Okay, from the right side, limit f of x towards from the right side, it is negative infinity. Why? Because as I increase more zeros, I'll show you, as I increase more zeros, the number grows larger and larger. Okay, and it means it's going towards negative infinity. Positive infinity, negative infinity. Positive infinity means it's becoming a positive big number in terms of billions and billions. Negative means it's a minus big number, but it's a very small number because it's negative, right? It's going to be a very, very small number. Can you see these limits are not same? So what you tell is the limit of this does not exist, does not exist. Or you can write D and E. That means the limit is not there. This is what you can do the tables and you can solve, and you will understand the left side and the right side. Both the one-sided limits are not the same. You can see over here, we have the same thing, right? As it is minus one-sided limit of limit g of x, the function is taken as g of x. You can take anything, f of x, g of x, y of x, anything, it's fine. So g of x is positive infinity, whereas limit of g of x when positive over here, when it's positive, it's going to be negative infinity. So what happens is the limits are not the same. So when f of x, limit of f of x, 2 from the right side, positive, 2 positive means right side, it is negative infinity. It's not the same, and therefore the limit does not exist. So that is it. So this is the thing. If both the values are same, then and only then we can tell it exists. So now if you're thinking, what if it was plus infinity on both the sides? Then yes, the limit of this is equal to infinity. It's just a big positive number. That's it. If both were going to positive side, yes, it exists. But now it was different, therefore it does not exist. Over here now we have the graph, and we have been told to find these particular values. We will directly do this. You can see the explanation later. Now this is a one-sided limit, limit of f of x as x approaches 1 from the left side. Let's see. 1, positive 1, where is it? Over here, right? From the left side means from this side. Where is the what is the value? See, you can't consider this graph at all because this is only from the right side. From the left side, the value is 2. So the answer for this is 2. Now what about the next answer? Next question. From the right side, same point at x1, but from the right side, what is the answer? It is minus 1. Now over here we have limit of 1. Now look, left side it is minus positive 2, right side it is minus 1. Can it have a limit? No, it does not exist. So both the sides are two different values, so we just write do not exist, because this over here is after comparing both the one-sided limits. First you should see the left one side of the left side and then the right side, and then you finally give the answer. Now coming over here, limit of f of x as x approaches from -1, that means you must see the left side and the right side. Isn't it coming to the same point? Both are corresponding to y of 1. So yes, this exists and the value is 1. Why? Because from left side and right side both are coming to 1. So these are the answers. This is the explanation. We can see the first answer from the left side is 2, right side is -1. So it does not exist. They are not equal limits, or both the one-sided limits. And this was, yes, both sides equal, it's 1. Now there's another problem over here. just quickly look at this. Why? Because you can't directly solve it. Why you can't solve it over here is, if you put this 3 over here, minus 3 whole square minus 9, it's going to be 9 minus 9, 0. The denominator is 0. So that, you know, at this particular point, there's a hole. It does not exist. But we can find the values near to this, right? The graph won't be given. This is just for your understanding, but you do not need the graph. But if you have the graph, you can see from here and here, they're approaching towards the same point. The value is negative half, so the value is negative half. Okay, but how do we do directly? Take out your calculator. Now over here, since it's minus 3, I will take a value. Let me write the points. Less than and greater than. Less than would be minus 3.001. Greater than would be minus itself, but 2.99. You know the negative values, the value smaller is greater than the huger value. So this is it. Now let me consider 3 multiplied by, open the bracket, minus 3.001, close the bracket, plus 9 divided by, open the bracket. See, don't forget to use the bracket over here because there's negative value. If you don't use the bracket, the square will only be to the number and negative sign will sustain and your answer will be wrong. So always remember to use the bracket when there is minus 9. Okay. Now this is just minus 9 as it is, but the x was negative, so, and it had square, so I had to use the bracket. So we are getting 3x plus 9, and okay, let me put the value. Let me see the answer. It is 0.4999. It's almost negative 0.5. Okay, this is at negative 3.001. Let me now change this value to 2.99. Let me just change it over here quickly, 2.99, and over here as well to negative 2.99. And let's see the answer. It is again negative 0.500. It means it's 0.5 only. Both the values are same, so both the one-sided limits, negative and positive, both correspond to the same answer of negative 0.5. Yes, therefore it exists. So this is the answer. And you can also solve it by, you know, factorization. You can use the identity, split the terms, cancel it off, and you're remaining with this answer. Substitute, you'll get the answer. So this is the thing. But here the very important thing is x cannot be plus 3 or minus 3. Let us substitute over here as plus 3, for argument's sake. Denominator, if we have just 3 also, it will be same thing. 3 square is 9 minus 9 equals 0. So we can't have, x cannot be equal to plus or minus 3. That is very important. So this is how we solve it. Okay, but the limit of as x approaches minus 3 means it is what it corresponds to. It is not at this exact point, but nearby that point. So that exists. Now another problem where it does not exist. So same method, same thing. Let me just do it and calculate it quickly. Now we have value of 3. So one value is less than 3, that is 2.99, and then 3.01. Okay, let me quickly substitute and do it. This is just the shortcut method, you know. Into 2.99 plus 9 divided by 2.99 square minus 9. Now I'm not using the brackets because there's no negative sign, right? So it's fine. I'm getting negative 300. Let's just write it. Okay. And if I just increase the zeros, it'll be a bigger number, you know, negative 300, 3000, 3 million, and so on. Now let me make it 3.01, and here as well 3.01, and you can see the answer is positive 300. Positive. It's a huge difference because it's plus or minus. So let me increase these values. So you can see it's increasing. Now it is 300,000, it'll be 3 million, 3 billion, and so on. So it is One-sided limit is negative infinity and positive infinity, so it does not exist. The final answer would be does not exist. That's it. So approximating the value of limit. Now we have over here limit of x as x approaches 0 for this function of sine x divided by x. Now if we directly put in the calculator 0 in the denominator, it's undefined, right? What is the answer? See, what we do is we take values very close to 0 and search. Positive, negative, we have done similar thing, and the answer is 1, and therefore we consider sine x by x to be 1. We can do this again in the calculator directly. I'm just showing you. And one very important thing which I mentioned in the last video, now here x will be 0.00. Okay, there is one more method. I hope this is not confusing, because some students get confused in this method. So I just type in the values. I write like the 0, negative 0.001 and positive 0.01. Let me just write 0.1. Okay, so these are the values, right? Now every time, instead of deleting and changing it, you can substitute, say here x, sine x, okay, and divided by x, and then you can assign the value of x to be, wait, first let us make into radians. Shift mode, sorry, I have not pressed shift mode and 4. Only now I will get the correct answer. I had mentioned this previously, so please remember about this. And now I need to assign the value of x. Okay, I'm just a bit rusty because now I'm not figuring how to. Okay, anyways, I will tell about this method in the next video, because you can consider like this, and then all you need to do is just assign the value of x. So there is a method. Now I'm not getting it. Okay, I'm not understanding exactly how to do that, but you can just assign the value of x to be negative 0.001. You will get one answer. Write it. Then no need of changing it. It will be remaining the same, but all you need to do is assign the value of x to 0.01. I will definitely tell you this method in the next or the coming videos. Sorry, I just missed the exact way to do it. But anyways, but generally this way, just to make it negative 0.01, changing is also fine. This will definitely give you the correct answer. So over here now I got 0.999, and now all I need to do is take the negative sign off, and the answer is again 0.99. Both are corresponding to 1. Yes, the limit exists because both the one-sided limits are towards the same answer. Now, very important thing to know, this will come in the future as well. This is like a formula, like a qanun. So this is an important thing you must remember. Whenever you see this, it's always equal to 1. Okay, in the future you will have to use it as a formula. So that is the thing. And over here we have the absolute value function. Now it's the same thing over here. Whenever you have absolute value, what happens? You take a negative value or a positive value, it's the same. It will be positive itself. Now same thing, don't take zeros, take 0.001. You can just check it out over here. You can use for absolute value shift and HYP, because the upper value is absolute. Okay, now it is x. We can't take x as 0. We need to take 0. The closest value to 0 are 0.01 negative and 0.01 positive. So let me start with the lower value. So negative 0.01 and shift absolute value 0.0 negative, sorry, is equal to -1. Now you change the values to any number. Okay, 0, 0, it'll be the same thing because you're dividing by the same number. It's going to be always 1, but the sign changes depending on whether it's positive or negative. Because it's negative in the numerator, the negative sign sustains, whereas if it's positive, it will be positive value. So that's the answer over here, you can see. And if it's positive, in the denominator it does not matter whether it's positive or negative, it's the same thing, only above it matters. Now it's positive, so that's the thing. And at this particular point you should have a hole over here. You know why? Because you can't have 0, it's undefined. But now this is the thing, it does not exist for absolute value functions. Why? Because both the one-sided limits are not the same, right? One of the limit is positive 1, one more is negative 1. It does not exist. That's it. So this is how we solve it up. And last real world problem, we'll quickly go through this. The knuckleball is one of the most exotic pitches in baseball. Batters describe the ball as unpredictably moving left, right, up and down. For a typical knuckleball, the speed of 60 miles per hour, the left or right position of the ball in feet as it crosses the plate is given by this particular equation. Okay, derived from experimental data in Watts and Bahel's book, Keeping Your Eye on the Ball, where omega, the symbol W, sort of omega, is the rotational speed of the ball in radians per second, where function of you can consider this just as function of x or f of x or function equals 0, corresponds to the middle of the home plate. Folk wisdom among the baseball pitchers has it that the less spin on the ball, the better the pitch. The less spin, the better the pitch. To investigate this theory, we consider the limit of the function of omega, as omega corresponds to one-sided limit from the right side, 0 of positive. As always, we look at the graph, see this figure, and generate the table of function. The graphical numerical evidence of this is given over here. So basically, you have to just understand, analyze, like make a table, and then tell about this function. Okay. So I'll just tell what this question is. It's basically a more like an understanding problem rather than a question answer problem. This is a given function. So in baseball, what happens is they have something called knuckleball. When they throw the ball, they give it a spin. So what happens is, now this batter will be looking at the person's hand when he releases, and he tries to hit the ball, right? But with the knuckleball, there's a spin to it. So instead of like when you throw, if this is the baller and this is the batter, when he throws the ball like this, the batter assumes it will come over here. But with this knuckleball, it usually adds a spin. It will go somewhere over here, up or down, or it might be sides. That is the speciality of the ball. And this is the function of that knuckleball thing. And you can see the graph over here. So let's see the graph. As the, what is omega given as? Rotational speed. See, as the rotational speed varies, what is this? Corresponds to the middle of the home plate. Sorry, for the typical left and right. Okay, the batter described and moving for a typical number speed. Okay, this is the rotational speed. And okay, I'm just getting confused. The left or right position of the ball in feet. Okay, how it changes. Okay, so now over here, this is the change. Okay, this is the function where how it changes and everything, the spin to it. Okay, this is the spin and this is the rotational speed. As you can see over here, at 2, that's the highest. And then it sort of reduces. So this is very important. Now from this graph, we can see the most optimum rotation omega, the rotational speed is at 2. Okay, why? Because over here it varies and then it keeps on going. So now we are basically, this is a simple graph. There's nothing to it. All you do is you substitute the omega values, the rotational speed. Maybe it's considered to be 10. What is the value? 1. I'll just do one value quickly. So 1.7 omega is considered as 10 divided by 10 minus 5 divided by 8 into 10 square. Whatever you consider the same must be throughout, into sine 2.72 into, again it is 10. close the bracket. My mode is already in radians, so I should get the correct answer. This is the answer. Same way, if I just change it to say 0.1, I'm just making, if I add a decimal point, it's going to be 0.1 into 0.1. Now you can see it is 0.288, so on. So as you vary, you see as the speed increases, this reduces. So now what it says is the limit indicates that knuckleball with absolutely no spin does not move. See, as you go to 0, if there is no spin to the knuckleball, this moving is there, right? Up or down, it just doesn't happen. But if you give a certain spin, the rotational rate about 1 to 3, it produces the best pitch. See, this is the best movement, it happens. So for about 2 to 3 value, you get the best pitch. So that is this figure is the thing. So basically that's it. It's not a proper typical problem. It's just for you to understand how, you know, a simple thing varies, and you can see the graph and you can understand how to solve this. So this is it. But most important thing in this lesson is about the limits. So limit is not exactly to one particular point, as we saw a while ago. Now if I ask you the limit at 0, it's not at that particular point, it is before and after that point. If you understand this concept in this lesson, that is more than enough. And if you have understood how to solve it, please keep that in mind. You should take a value less than and greater than the value it is approaching, and then solve it up. So that's the end of the second lesson. I hope you found it useful and helpful. Do like and share my videos, and if you're not subscribed to my channel, please do subscribe. It would mean a lot to me. And please do stay tuned for the next video. Thank you guys. See you soon.